write a code fragment which adds the 32-bit contents of 8100 low significant bit, 8103 most significant bit. So this is a range provided 8100 to 8103. Okay, and 8104 to 8107. This one add with this, and store at this location 8100 to 8103. Okay, and that's A part. So in the A part, what we have to basically do it, we have to just add this range with this range, and then store it in this range, and that is 32-bit. And also the B part is asking write a similar code fragment which adds the 8-bit BCD contents of this range to this and stores it over here. Okay, so let's see how to do it. First, let's deal with the A part. In the A part, it's mentioned it's 32-bit. It means we have to divide this one into 4 parts, because when we are using accumulator A, we have to take care of 8-bit at a time. So if it's 32-bit, then we are going to have 4 parts. So let's mention that here. Divide the 32-bit. Number into 4 bytes. 1 byte is equal to 8 bits, so 4 bytes is 32 bits into 4 bytes. L1, L2, H1, H2. L1, L2, H1, H2. Where L1 is least significant bit. And H2 is the most significant bit. In the order, that order. So let's deal with the least significant bit first. Least significant is mentioned here. First one is 8100. So we have to load this one first. LDAA, load into accumulator A. Then we meant the address, that is 8100. And then we have to store this one. And we have to add this one with this, then store. So to add this one, we use the add to accumulator A. And we are adding the first one because it's given respectively. Least to the most, least to the most, least to the most. So we have to follow in the exact same order. So we have to add this one with this 8104 and store it at this one 8100. STAA 8100. Okay, now this is the L1 part of it. Okay, and the next digit is L2. If you look at the range, 8100 to 803, so we are going to have 8101, 8102, and then 8103. So we have to add 8101 to the next number of this, that is 8105, and then store it in the next number of this, that's 8101. And then like that we have to increase one by one until we reach this range. And when we reach this range going from 0 to 3, you can see the last digits 0, 1, 2, 3. So we have to do this one like 3 more times in order to complete this code. So let's do the second one. So you have to just keep up with the numbers. Each of these numbers just going to increase by 1 each time, and it's going to end in the last range in the fourth one. Okay, let's do that. I mean, here B part we will do that separately. LDAA, and the next digit of this one is 8 8101 and then AD. But for the second one we had to use the ADCA. First one we can directly add it because we don't have any carry, but second one we are going to deal with the carry, so we use this term called ADCA, that is add with carry to A. Okay, only the first one comes as ADDA. That's the difference. Other than that, we just increase one number, so 8105, and then STA 8101. This is L2, and I had to continue, downward, but I don't have space, so I'm gonna continue over here. And then the third one is LDAA, and the next digits 8102, and then again we are going to have carry, so ADCA, and then the next digit of this one is 8106, and then store it in the next digit of this, that's 8102. And this one is H1, and the last one is LDA, and increase one digit, that is 8103, and then ADCA, and then increase one of this number, that is 8107, and STA, and that's the other one more digit of, that's 8103. Okay, so this is H2, and let's double check the range. This one 8100 to 8103, so we take care of that range. 8100, 800, 101, 102, 103, and the adding part is 104 to 107 range, 104, 105, 106, 107, and the storing part is 100 to 103 range, 100, 101, 102, 103. We take care of all of them, and that's it for this code. And if you want to explain what happened here, we can just write this one by the execution of this code. The contents of (8100) to 8103 are added to the contents of (8104) to 8106, stored in (8100) to 8103. Okay, this is the process what happened over there. Okay, that's the A part of it. And then B part is very similar. Write a similar code fragment which adds 8-digit BCD contents 8200 to 3 and 8203 to 804 to 8207 and 8 storage to 8200 to 803. So it's similar thing, but the thing is, when we are dealing with BCD, we had to put a DA, that is decimal adjust accumulator array. We had to do that for wherever the addition happened, because that will correct a hexadecimal value into a BCD. It will add wherever, if the value, like for example, if I have 9 and a 6 added, that value goes above 8 and become F. But what does the DA instruction do is add an extra 6 to it and make the adjustment to the BCD. Okay, if it goes above 9, it does that. So we had to add that term after every addition process. Now let's see how it's gonna look like. I'm gonna create a new page. The B part. Again, start with the first one, least significant bit. In this case, that is 8200. Load that one. LDA 8200, and then we are adding that one with 8204, and after the addition process in a BCD, we have to use DAA. This is called decimal adjust data in accumulator A to BCD. This is just a comment, that's why I put here. This is just explanation, not in the code. Decimal adjust data in ACCA to BCD. Okay, this is what this one means. And then after that we had to store it, STAA, and the place we're going to store it is right here, 8200. Okay, and like the one we did before, it follows the exact same pattern. Each time increase by 1, and it's going to be 4. It has to be done 4 times to complete this range, because you see 8200 to 003, so it means 0 1 2 3, so that's in that range 4 5 6 7 0 1 2 3. We have to just increase each of these loading value, adding value, storing value, and do it for all of them. So let's do that. Now second part is LDAA 8201, and then AD. Now we are going to deal with the carry. First one we can add directly, but second one we are going to deal with the carry. So ADCA, then 8205, here's 4 5, and then after the addition process we use a decimal adjust accumulator A, STA, and then we have the next digit is 8201. Okay, and then next one, increase one number, LDAA 8202, ADCA 8206, DA instruction, then STA 8202. Now we have done 3 of them. I need 4, so I just remove this explanation here. Okay, so this is like continuous downward, but I don't have space, so I do it here. LDA 808203, and then ADC 8206, and DA instruction, and STAA 8203. Okay, so this is the first part. Like let's look at the range. LDA That is the first one. 200 to 203, 200, 200, 201, 202, 203. And the adding part is in the range of 204 to 207, 204, 05, 06, 20, yeah, 207. Okay, and then DA instructions will be followed after every addition process. And then store STA, that is in the range of 200 to 203, 200, 201, 202, 203. Okay, and that's basically it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.